Welcome to my next tutorial on electronic structure, particularly aimed at A-level. So I'll assume you know the idea of electron structure to the point of energy levels, that being shells or energy levels where the first shell has 2 electrons, then 8, 8, and so on. So if we go back to that, if you remember, then the first electron shell, there you go, just labelled there, and we've got the second, just there, and then the third. Okay, so in the first shell we have 2 electrons, second has 8, third also has 8. But notice, just for a second, that we've got one block of 2 in period 2 in the second energy level, and then 6. And the same in the third, the 2 and then the 6. So we can call these energy levels, we can call them shells, or to give it a new term for A-level now, we're going to call those, just coming up here, principal quantum numbers. I won't go into the detail too much on quantization or the quantum nature of the electron for now. I'll leave that for a different tutorial. But coming back to the energy levels, you can see they're split into the 2 and the 6. What we're going to call those now are orbitals. Okay, so each principal quantum number or energy level is made up of orbitals. You can see the shapes just coming up here. So the first shell has just one orbital, and each orbital can take a pair of electrons. There you go, 2e minus, sorry about the minus there. So the 1s just has the 2 electrons in it, that's the ones for hydrogen and helium. Then after that we would fill in the 2s, okay, and that would also take 2 electrons. And moving on the diagram, you can see the shapes of the 3 p orbitals. Okay, 3 lots of p orbitals, each orbital takes 2 electrons, and you can see the shapes there along the x, the y, and the z axis. You should note as well that those orbitals, those yellow lines, that's not actually the lines the electrons will follow. They can be anywhere in those orbitals at any point. So let's have a look at the order of how we fill up orbitals now. We go from the 1s, we fill up 2s, then 2p, 3s, 3p, but we don't jump to the 3d, we go straight down to the 4s there, and once that's full up, then we go to the 3d. So one of the most important things to be able to do then is to take the idea of orbitals and to be able to write out the electronic structure if you're given a particular element. You can see I've got 3 examples here that I'm going to fill in for you. So the first one is lithium. Lithium has an atomic number of 3, so we're going to have 1s2, there's 2 electrons in the 1s. We've only got one more left, so that will be 2s1. So lithium, 1s2, 2s1. Then we've got nitrogen, atomic number 7. So 1s2, 2s2, that leaves us 3 more electrons. So there, if we look up at the diagram, they're going to the 2p, so it's 2p3. There we go. Last one is silicon, so we'll follow the same pattern again, 1s2, so we fill up the s orbital on the first shell, or the first quantum number, 2s2, that one's full up, 2p6 this time. So we're up to atomic number 10, I think silicon is 14, so we need 3s2, and finally 3p2. Okay, we can also do this in shorthand. It's a bit long to do this sometimes. We take silicon, we can go back to the nearest noble gas and simplify it. So we can take out 1s2, 2s2, 2p6 and put in Ne in brackets, 3s2, 3p2. Well, that concludes the tutorial for today. Hope you liked it. We'll be back very, very soon with more.